Welcome to The Explainer. Today we are putting on our detective hats. We're going to piece together the cosmic clues that reveal not only that our universe is expanding, but that its story is a whole lot stranger and more complex than we ever thought possible. All right, let's just jump right in with this question. And it's a fantastic one, because it really gets to the heart of the matter. How do we know what we claim to know about the universe? The answer, it turns out, is all about cracking a kind of cosmic barcode that's hidden in the light from distant stars.
So, to solve this cosmic case, we first need a crucial piece of evidence. We need a reliable way to identify different elements and molecules, even when they're billions of light years away. And lucky for us, we have a technique for that. It's called spectroscopy.
Here's the best way to think about it. Every single molecule out there has its own unique barcode made of light. The specific pattern of light it absorbs or emits is hard-coded by the laws of quantum mechanics, and that means its barcode is the same here on Earth as it is in a galaxy on the other side of creation. It never, ever changes. It's a universal constant.
So check this out. When we point our instruments at a distant cloud of gas, we find the unmistakable barcode for carbon monoxide. The pattern itself, the spacing between the lines, it's a perfect match. But the entire pattern is shifted over to slightly lower or redder frequencies. The fingerprint is correct, but it's been moved. So the question is, what's moving it?
You already know this phenomenon, even if you don't think about it. It's the Doppler Effect. Think about a train whistle. As the train rushes away from you, the pitch of the whistle drops, right? Well, light does the exact same thing. Light from an object moving away from us gets stretched out to lower, redder frequencies. And this, right here, is the first huge clue in our cosmic detective story.
Simple enough, right? When that light pattern shifts towards the red end of the spectrum, we call it redshift. That tells us the object is moving away. If it shifts toward the blue end, we call it blue shift, and that means it's coming towards us, like the Andromeda galaxy, which is on a collision course with us. But here's the thing. When astronomers looked deep into space, they found that almost everything was redshifted.
And that realization, that nearly every single distant galaxy is running away from us, that led to one of the most profound, most reality-shattering ideas in the history of science. It completely changed how we saw everything. So back in 1929, an astronomer named Edwin Hubble noticed something incredible. He found a stunningly clear pattern. The farther away a galaxy was, the more its light was redshifted. In other words, the faster it was moving away from us. It was this perfect, undeniable relationship. Farther away meant moving faster.
Now, this brings up a pretty obvious question, one that you're probably thinking right now. If everything is moving away from us, does that mean we're special? Are we sitting at the dead center of some great cosmic explosion? I mean, it's a tempting idea, but it would make our little spot in the cosmos unbelievably unique.
The actual explanation is just so much more mind-bending and elegant. The idea is that the galaxies aren't flying apart through space. No, the fabric of space itself is expanding. The best analogy is dots on a balloon. Imagine you draw a bunch of dots on a deflated balloon. As you blow it up, from the perspective of any single dot, all the other dots appear to be moving away. And here's the kicker. The dots that are farther away appear to be moving away faster. There's no center on the surface of the balloon. And in this story, we're just one of those dots.
So, this elegant model of an expanding universe became our standard theory, our bedrock for decades. But like any good detective story, just when you think you've got the case all wrapped up, new evidence starts to pop up. And suddenly, there's some pretty shocking plot twists.
The first really big complication, the first crack in this beautiful model, actually comes from the very ruler we used to measure those enormous cosmic distances in the first place.
You see, to measure distance across the cosmos, astronomers use what they call standard candles. These are objects that are supposed to have a consistent, known brightness. And for a long time, the gold standard has been a very specific kind of exploding star, a Type 1A supernova. The logic is simple. If you know exactly how bright a light bulb is, you can tell how far away it is just by how dim it looks. But here's the problem. It turns out, our standard candles might not be so standard. The classic idea was that they all explode when they hit a very specific mass. But a new hypothesis, with a lot of evidence behind it, suggests a double detonation can happen in smaller stars. And that means not all these explosions are identical. And if they're not identical, our cosmic yardstick is wobbly, which means our calculation for how fast the universe is expanding might be off. So our cosmic rulers are being questioned, and on top of that, the James Webb Space Telescope, our incredible time machine, is looking back to the dawn of the universe and finding things that just flat out shouldn't exist according to our models.
JWST has found these massive galaxies, they've nicknamed them Sleeping Beauties, that just went dormant, only a few 100 million years after the Big Bang. This is a time when our theories say they should have been frantically building stars, not just shutting down production. It completely upends our idea of how galaxies grow, suggesting it wasn't a smooth process, but a chaotic one. Crazy bursts of creation followed by long, quiet naps. Now, these new clues about supernovas and ancient galaxies are fascinating, right? But they all seem to be pointing toward an even bigger, more profound mystery, the idea that most of the universe is completely, totally invisible to us. Here's the deal. When we look at how galaxies spin, something is deeply, fundamentally wrong. The stars way out on the edges are moving so fast, way too fast, that they should just be flung off into deep space. The only way they can be held in orbit is if there is a ton more mass, and therefore a ton more gravity than what we can actually see.
This missing mass is the single greatest unknown in all of cosmology. We call it dark matter. It doesn't emit light, it doesn't absorb light, it doesn't reflect light, it does nothing. Except its gravity seems to be the invisible scaffolding that the entire visible universe is built upon.
So how on earth do you find something that's literally invisible? Well, one of the big ideas is that maybe, just maybe, these dark matter particles aren't perfectly stable. Perhaps one might decay every now and then and release a tiny fleeting flash of light. So right now, scientists are using our most powerful telescopes to stare into the dark, just listening for that faint whisper from the invisible universe. This whole hunt for incredibly faint, natural clues is pushing our technology to its absolute limit. And that push has some scientists asking a really wild question. What if some of the signals we're looking for aren't natural at all? What if we should also be looking for artificial signs, for what we call technosignatures? Take a look at this, for example. Normally, when a planet passes in front of its star, it makes a nice, simple dip in the starlight. But this simulation shows something totally different. This is a planet surrounded by a huge, dense belt of satellites, what's called a Clark exobelt. You can see it would create a really distinct, messy, and frankly, unnatural-looking dip in the star's light. It's a signature that nature would have a very hard time faking.
And that leaves us with one last, really provocative thought. As we keep trying to solve the mysteries of our expanding universe, from redshift to dark matter, we have to wonder, what if the next revolutionary clue, the next game-changing piece of evidence, isn't found in an exploding star or an ancient galaxy, but in a signal that tells us we're not the only ones out here asking these questions?